Okay, today we are going to start the 6.2, which is the calculation of trigonometric functions of any real numbers, which is quite similar to in the previous sections that we learned trigonometric functions of any real, any angles, basically. So now we are going to take any real number representing a radian measure of an angle. So that's why we can just say trigonometric functions of a real number, which represents a radian, the measure of an angle, of course. So it's just a different terminology. It's completely the same as calculation of the trigonometric values of the angles. So we will see the concept of trigonometric functions of the arc of a unit circle. So it's a unit circle, so we need to, be careful about not any circle. So we will see why it is like that, and we will also see the fundamental identities again that we covered it before. Now, again, let's remember basic definition of trigonometric functions, and we have a terminal side of an angle, and we have the point on a terminal side, any point, of course. And we remember sine and cosine definitions, tangent, cotangent, similarly. Maybe we should have a practice for this question. Suppose I have a 150 degree and the point is given with a certain distance from the origin, so that the x squared plus y squared is 16, and we are asking what is x plus y. And now, so let's just use the definition of sine of theta. So we know that sine of 150, right? Sine of theta is given by y divided by r, right? And in this case, everybody, r is 4. It is y divided by 4, correct? Because r square, right? Yes. R square is equal to x square plus y square, which is 16. So r is root of 16, 4. So we know that this distance from the point to origin is 4. Well, do we remember a sine of 150 degree before, everybody?
Half.
Yes. First, let's go to reference angle, right? Remember, we use the reference angle, which is here, right? It's yes. a 30 degree. So reference angle, it's, let me erase this one and write it a little below. So we have sine of, it is the same as sine of 30 degree. Okay, screen is acting a little weird. I'm sorry for that. So it is y over 4. So we know sine 30 is half, right, everybody? So it is y over 4. And from here, we get y equals 2. Right. Y equals 2. So how do you find the x value if you know the y value? Well, we have option to substitute, right, Shiva?
Yes, x square plus y square equals r square.
Yeah, you can substitute. Let's substitute here, right? So you will get x square plus 4 equals 16. So you will get x square equals 12. Am I right?
Yes.
From here,
2 root 3.
so it is positive or negative, right? We are taking the root.
Yes.
Because of the second quadrant, everybody, you will get a negative 1. So it is negative, what is that? 2 root 3, am I right?
Yes.
All right. Now you know the x value and y values of this point. Okay. Now imagine.
2 minus. We add them right now.
Yes, you can calculate x plus y, right?
Yes.
But well, I can calculate y in another way. We remember cosine of theta, right, Shiva? Cosine of 150 is x over r. Right? This is the definition of cosine, which is x over 4. And what was the cosine in the second quadrant? It is negative cosine reference angle, correct? Negative of cosine reference angle, which is equal to x over 4. Well, negative cosine 30 degree is in negative root 3 over 2. So equals x over 4. And from here, you will get the same result. So x equals negative 2 root 3. And it looks like substituting into, a y value into equation gives you the x value a little quicker than this one, right? But anyway, so we just need to remember the, how to use the cosine definition. Well, of course, it just depends on the location and also depends on the r value. In this case, r is 4. So if you change the location, suppose you just choose a location, the point is again on the terminal side, but now it is closer, right? It is closer to origin now. So definitely the x and y coordinates will get, a different, right? But now imagine, everybody, that if the distance of the point to origin is just 1, that makes it quite easy and simple. Because if r is 1, then sine of 150 will be directly equal to y value, right? Because if r is 1. So that makes the calculations much easier. It will be y equals 100 theta, and the x is equal to cosine of 150, and y is equal to sine of 150. All right. So that is the idea we will see next. You see? Yes.
The last class we took 5.3, right?
Yeah.
Did we finish it?
Yes, 5.3 we finished.
After 5.3, it's 6.2, right?
After 5.3, it comes 6.2 according to the syllabus, Shabab.
Oh, okay. So there's no 5.3.
Yeah, we are following the syllabus.
Okay.
All right. All right. So now imagine the point is on the terminal side, and also the R is 1, you know. Suppose R is 1. That means basically the point is also on the unit circle, right? Because the radius is 1, so the point is on the unit circle, everybody. Well, then, you know, as I said, sine of theta will be y over 1, so which is y. So sine theta will give you the y value directly, and cosine theta will give you the x value of the point, which is, you know, on the unit circle. Okay, so now the concept of trigonometric functions of arc in the unit circle. Of course, we are, you know, using the unit circle, because in the unit circle, everybody, the arc length is gonna be the, you know, the same as the numerical value of the theta. Remember, how did we calculate arc length, everybody? We used the letter S, but now we are using T. So I hope you are not getting confused. It's just a matter of different letter. Remember, the arc is given by R times theta, huh, Sheba?
Yes.
But in this case, R is 1, so the arc is gonna be the same as theta. Huh? So just make sure you are not getting confused, Shabab. The theta is representing angle, of course. The arc is representing, you know, the length of the, you know, this red piece of circle, length of the arc. So that is the T. So, but they are equal, you know, in terms of numerical value. All right, they have the same number. So one number is representing an angle, another number is representing a length. Like a 2 radian means it is an angle, but a 2 centimeter means it is a length. But they are both 2, right? You know, in that sense. So don't get confused, all right? So T and the theta are the same, you know, in this case, in this context. Now, when I write a cosine of T, you know, cosine of T, we mean cosine of the theta, of course. Okay, cosine of the theta, because T is the same as a theta in a numerical value, Shabab. So when you hear, you know, in the book, you know, what is the trigonometric cosine of the, you know, the arc? Well, we know cosine of an angle. We didn't know what is the cosine of an arc. Well, cosine of the arc is the same as the cosine of the angle, which is, you know, generated by this angle. Okay, which is intercepted by the central angle theta. Okay, except you know, the terminological difference, it's just the same calculation, you know, same idea of, you know, same technique to calculate the, you know, cosine and sine of the angle. So this is the new concept, but I am not sure if we should cover this concept in the orientation program. And so, which is the name is called the circular functions because of this kind of you know, concept, trigonometric functions of a the arc on the unit circle. And now you will think that what are we going to do if the theta is a negative angle? So do we have a negative arc? Well, in that case, we are using the direction of the arc. You see, we are using the arrow here, you notice. So now we have a direction of the arrow, right? So it is the same as the direction of the theta, counterclockwise. But if you go to the opposite side, this one, here, for example. So now this will be the negative arc because of the direction, just like an angle. All right. So of course we don't use a negative the length, of course, right? But when we use the negative, that means we have a clockwise direction, and the counterclockwise direction is going to give you the positive arc. All right. So that is the concept of circular functions, trigonometric values of unit circle. Okay, here, for example, we have arc, which is the length of the arc is pi over 4. You see? Why? Because this is unit circle, and this angle is, let me draw angle for you. And this angle is pi over 4 radian. Huh? You see the same number, by the way, right? Because the r is 1. Right, Shiva? So the arc will be the same as the central angle. So what is the x coordinate and y coordinate, everybody? So x coordinate will be the cosine of the pi over 4. Either you can say cosine of the arc or cosine of the central angle. It is the same because they are both pi over 4, Shabab. Okay? So that's why you should not get confused. What is the cosine of the arc? Okay, so the x value will be cosine of pi over 4, which is root 2 over 2. And the y value will be the sine of the pi over 4, again, root 2 over 2. All right, so you see on the table, some, coordinates of points depends on the arc or the central angle. Right. If you like to see the point coordinates of a point with central angle pi over 6, then you need to calculate cosine pi over 6 will give you the x coordinate, which is root 3 over 2, and sine of pi over 6 will give you the y coordinate, which is half, of course. And so I put you just a couple of clear example here. For example, if the arc is pi over 2, what is this pi over 2 now, Sheba? Is it an angle? Huh?
Yes, the angle.
Yeah.
So now this pi over 2 is the length of the arc, Sheba.
Yes.
So pi over
And
2
it's
is
equal
the
to the angle.
length. If you like to see the angle is here. It is pi over 2 radian. All right.
So
that is why in the unit circle, so arc will be the same number, but it is a centimeter, right? Centimeter. So a t is pi over 2 centimeter length, right? Now, what is sine of pi over 2? We know that 1, and cosine of pi over 2 is 0. So the point, which we call the terminal point of the arc, basically, is like a terminal side of angle. So we call the point as terminal point of the arc. So the terminal point of the arc pi over 2 is 0 and 1. All right. But if you try to calculate, everybody, tangent of pi over 2, well, tangent of pi over 2 is y divided by x, right?
Yes, undefined.
Well, it is 1 over 0, undefined. Exactly. And the secant is how? The r divided by x. Remember? Secant. R divided by x. Again,
Yes.
it will be 1 over 0. You see? Undefined. So it is undefined. So some functions, some trigonometric functions are not defined for some, angles. All right? For some angles. All right. So now I put this in nice picture I found it from the internet. So I thought it's going to be helpful for you guys. For example, here you see it 30 degree or pi over 6. So this angle is pi over 6 here. Pi over 6 radian. And it is the same as the length of this arc here. You see, Shabab? Length of this arc is also pi over 6.
Yes.
Pi over 6 centimeter. Okay? Just to make sure that still somebody is confusing maybe pi over 6. So arc is pi over 6 centimeter. Now, this is the terminal point of the arc, you see? And it is the, if you calculate a cosine of pi over 6, it will give you the x coordinate, which is root 3 over 2. And the sine of pi over 6 will give you the y coordinate, which is 1 over 2. So you just, if you practice these things, Shabab, it will, of course, help you to, remember how to calculate sine, cosine of these angles, which is actually almost all the famous angles that you are going to be, dealing with is available here. Right?
Doctor?
Yeah.
The arc of 11 pi over 6 equal to what? Is it gonna be a negative number?
11 pi over 6, the arc is 11 pi over 6. So you are talking about this arc here. You understand?
Okay, if I'm talking about the distance that between them, the nearest distance.
So now you are talking about this one.
Yes.
So now you have to say the negative direction arc. So just like a negative, the angle. So we are going to say the negative arc, yani the clockwise direction arc. So this arc is also negative pi over 6. And this angle is negative pi over 6.
Okay, thank you.
You see, Shabab, that is why it might be a little bit confusing concept for you guys. Masalan, how can I say the length of the arc is negative? Length cannot be negative. Of course, length is negative. But in the physics, Shabab, in the science, there is a directional, length, directional. So if the
Yes.
direction is, clockwise, so we will say it's negative. It's like the positive temperature, negative temperature. Well, how do you say negative temperature? Well, because it is below 0. If it is, in the below 0, you need to call it negative temperature. So something like that. So if the direction of the arc is clockwise, then we are going to call it negative arc. you know. Yeah. Yeah, of course, we don't mean like negative pi over 6 centimeter. No, it's not like that. It's a direction is clockwise. Huh? Is it, have I made your mind clear, Shabab?
Yes, it's just
Yes,
the opposite
thank you.
direction.
Yeah. So again, personally, I totally disagree to, you know, give this the concept in the math, you know, orientation program. I'm not sure if you need it in the Jebel or not. Okay. Anyway, now, so here is the things that you should be, you know, a little bit more careful, Shabab. Suppose we are looking at the angle in the standard position, right? In the first position, it is a 0 degree or 0 radian, right? In the first position. And when you rotate and okay, when you rotate and come here, it will be how much, Shabab?
Pi over
From
2.
Pi over 2.
This is pi over 2, right? You see? But the first time it is what? 0. So
yes.
0. Now it is pi over 2. Now how much, Shabab? Pi.
Pi.
Now how much, Shabab?
3 pi over 2.
3 pi over 2. Now how much, Shabab?
2 pi.
2 pi. Well, when you come here, you know, Shabab, you will see the first time 0. And second time, when you come back, 2 pi. When you come back again, how much? 4 pi, right? Come back again, 6 pi, 8 pi, 10 pi, right? So for the 2n pi, right? 2n pi, you will be always on the like a 0 position, right? 0 or 2 pi or 4 pi, 6 pi, and also negative. It is going to be the same as the 0 position. So you have the point on the terminal site is 1, 0. So now you can understand which functions are defined, which functions are undefined for these kind of angles, Shabab. Masalan, do you think cotangent of these angles will be defined? Cotangent.
No. Because
cotangent will be x over y, right?
Yes, it should be answered.
Yes. Now we have to remember cotangent of 0, 2 pi, 4 pi, whatever, yani 2n pi, cotangent is undefined. Well, how about if you come here? You will have the same problem. Because when you come here, Shabab, the first time is pi. Second time when you come here, it will be 3 pi, right? When you go around and make a full turn and come back here, that means you're going to make another 2 pi. So pi plus 2 pi is 3 pi. And another rotation will give you 5 pi, 7 pi, 9 pi, 11 pi, right? Yani, what is that? 2n pi plus pi. Yani the odd number pi. You see, Shabab? Odd number pi, you are always here. So the problem is the same. Because y divided by x divided by y will be undefined. Yani cotangent is undefined. Looks tangent is undefined here and also undefined here. Yani all the even times pi, also all the odd times pi, cotangent is undefined. So even pi undefined, odd pi is undefined. So that means cotangent is undefined for n pi, right? N times pi. Either n is even or n is odd. So n pi is undefined for cotangent.
When the y is 0.
Because the you know the y coordinate is 0. Okay.
Doctor?
Yes.
Can we say that I mean cosec 2 is undefined?
Yeah. Is cotangent clear first? We will come to cosecant now. Yes. Also for the cosecant is what is that? R divided by y, right? Cosec. Cosecant is the R divided by y. Well, because y is 0, again, cosecant is also undefined, right? Maybe also, let me write the tangent here. Not tangent. Not tangent. Cotangent, şebap. Cotangent is x over y. Now the y is the problem, right? So because y is 0 in both sides here, so cosec and cotan. So maybe you can remember it. The sounds there, you know, the names are quite sounding similar. Cosec, cotan. So they have problem with these angles. Okay. So now we should understand and keep in mind and remember every time. Cosec and cotan is not defined for what?
For
y equals 0.
Not defined for n pi.
Yes, any pi.
N pi. 1 pi, 2 pi, 3 pi, 4 pi, 5, whatever. N pi, okay? So it is undefined. N times pi. Problem is n pi.
But
So they are not
greater than 1,
defined.
right? And not
Yes.
equal to.
Huh?
N is not equal to 1, right?
N is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. You understand?
Yes, yes.
Doctor?
But doctor,
Yes.
go Khaled.
No, go for a question. I will ask something else.
Yes. Now, so when you come here, oops. I'm sorry. When you come here, Shabab, it was pi over 2, right? First time pi over 2. So who is undefined?
Tangent.
The tangent.
Ava. So
Secant.
10
and sec.
10 is y over x. Now the x is the problem here. 10 and sec r over x. Well, if x is 0, then tangent and secant will be undefined. So where is the angle, Shabab? Either pi over 2 plus 2n pi or 3 pi over 2 plus 2n pi. In both cases, x is, the problem. X coordinate is 0, so tangent and secant will be undefined. Well, so how can I write the both sides, Shabab? Pi over 2 plus 2n pi or 3 pi over 2 plus 2n pi. So we can write the pi over 2 plus n pi. The expression will represent in both location, For example, if n is 0, Shabab, let me choose my laser. So if n is 0, where are we, Shabab?
Hi.
We are here, right? If n is 0, we are here. if n is 1, what do you get?
3 pi over 2.
You get here, sir?
Yes.
You see? So if n is 2, what do you get? You get here. Pi over 2 plus 2 pi will be here. Yani as you change the n, you will get here or here. Here or here, right? So the expression is pi over 2 plus n pi. So these angles are the problem for tangent and secant. Now, when I ask you what is the domain of tangent, Shabab, or what is the domain of secant, you just need to say all the numbers except, right? Except pi over 2 plus n pi. All right. So what is the domain of cosec or cotan, Shabab? All the real numbers except n pi. Yes. This is what you have to remember, memorize, understand. Whatever you do, Shabab, please these two numbers, n pi or pi over 2 plus n pi, you will be busy with these two expressions, you know, until the end of Math 002. Okay.
Doctor?
Yes.
This idea only when the terminal side on the quadrantal side, right?
Yeah. These are, yes, these are all quadrantal angle, right?
Yeah.
Yes. These are the, you know, special cases. Yes. For the other angles, yes.
The n is the time it turned. How many turns? The revolutions? How many times it turned?
The n.
Yes.
The n times pi, Shabab. N is 1 plus pi. N is 2 plus 2 pi. N is 3 plus 3 pi. So it is not showing the rotation. For the rotation, lazım 2 pi, 4 pi, 6 pi, right, Shabab? Okay. Let's just finish this one now. So, so Shabab, if the angle is n pi, or if the whatever number is n pi, then it is not defined for tangent and secant, but for cotangent and cosecant, I'm sorry, for the cotangent and cosecant, the problem is n pi. For the tangent and secant, the problem is t equal pi over 2 plus n pi. And we give you a table here, Shabab, domain and domain of the functions. For sine and cosine, all real numbers. For tangent and secant, all real numbers except pi over 2 plus n pi. And for the cotangent and cosecant, all the real numbers except n pi. All right. That is the domain of trigonometric functions, Shabab. So calculations, again, we did it, you know, before. It's going to be quite similar, not similar, exactly the same technique, Shabab. How to calculate the trigonometric values of the angles, and we'll see practice. For example, how do we calculate cosine of this arc? Of course, we mean cosine of the angle. Which angle, Shabab, do we mean here? We are calculating the cosine of this angle here. You know, we are talking about this angle, yani. This is 2 pi over 3. Right. Yes. Yeah. So, what is the reference of 2 pi over 3? Pi over 3, right? Yes, exactly. So when they say, what is the reference of the arc? 2 pi over 3. The reference arc is pi over 3. because this and this arc length here also pi over 3 شباب. You know, this arc, right? This arc is pi over 3, which is the reference of the red arc. Yani reference of 2 pi over 3 is pi over 3, just like an angle. Reference of 2 pi over 3 radian is pi over 3 radian. Reference of the arc is reference arc pi over 3. Okay. So let's calculate, Shaba. Do we have a terminal point of the 2 pi over 3, yani terminal side? You see, this is the terminal side of the angle, right? Terminal side of the angle, but this point is the terminal point of the arc. You understand?
Yes.
Terminal point of the arc. Terminal point of the arc is what, Shibab? In the quadrant 2, of course. Terminal side is in the quadrant 2. Terminal point is also in the quadrant 2. So cosine of 2 pi over 3 is negative. Of course, cosine of 2 pi over 3 is equal to negative cosine of the reference arc, reference angle, whatever you say. So which is negative 1 over 2.
So, doctor, it's the same idea, but we have the arc and angle are equal, but with difference.
Yeah, cosine of the arc. So when you hear from somewhere, you know, if somebody talks about cosine of the arc, so don't get surprised. He's just talking about the angle, cosine of the angle, yani.
Yes.
Yeah. Again, Shabab, here, you see the arc is negative. How come arc is negative? Well, just like an angle, because the direction is clockwise.
Yep.
You know, direction is clockwise, so we call it negative arc, like a negative angle. Because if you like to draw the angle, Shabab, angle is here. You see, here is the angle. It is negative pi over 3, of course. And the arc is also negative pi over 3. And if you get confused, hey teacher, what do you mean arc is negative? So I don't mean the length is negative. So we mean the direction of the arc is negative. Okay. And of course, again, a reference angle is pi over 3, sir. Remember, we did this one before. Reference of negative pi over 3 is pi over 3. Negative pi over 4, reference pi over 4. Negative pi over 6, reference pi over 6, huh? Because reference is always a positive number. So we are going to calculate tangent. All right. So let's calculate the tangent, Shabab. So we'll see. Tangent of negative pi over 3 is negative because it is in the quadrant 4. So tangent of negative pi over 3 is equal to negative of tangent of reference. So tangent of reference is root 3. So it will give you the negative of root 3 as an answer. All right. If it is clear, let's go to another calculation, Shabab. So if you like to calculate a sine of 19 pi over 4. Yeah, well, 19 pi over 4 is too big, so we just subtract 4 pi to get the coterminal, right? Coterminal, the angle, or coterminal, the arc, whatever you say. So don't worry about the arc anymore. So 19 pi over 4 and 3 pi over 4 are the, same because they are coterminal. Now let's look at the reference angle of 3 pi over 4. Reference angle of 3 pi over 4 is pi over 4, of course, right? This is in the second quadrant, huh, Shabab? 3 pi over 4 is in the second quadrant. So the sine of 19 pi over 4 is equal to sine of coterminal. Coterminal, they are same, of course. and it is the same as positive sign reference in the second quadrant. So it is positive sign reference, which is root 2 over 2. All right. Next. Let me see if we have time to, yes. Let's calculate a cosine 17 pi over 3 together, Shabab. So what do you think? What shall I do?
minus 9 pi over
Find
3.
coterminal angle minus 4 pi.
Cosine of 17 pi over 3 minus, well, how about 6 pi, Shabab? Why not? Can I subtract 6 pi?
No, it will give us a negative.
So what is the problem? Yani, it doesn't give you the coterminal, yani?
It give us, but it's negative.
Khalas, let's see what's happening, Shabab. Let's see. This is what? Cosine of what, Shabab?
Minus pi over 3.
Aywa. Now, minus pi over 3, Shabab. Minus pi over 3. Well, it is good because it is easy to remember, know where is the location, sir. Where is minus pi over 3, Shabab? Negative pi over 3?
First,
Fourth.
third. Fourth factor.
Fourth. Because it's
Fourth
negative.
quadrant, Shabab. So fourth quadrant, cosine is positive, right? It is equal to cosine of reference. Reference of negative pi over 3 is positive pi over 3. Khalas, you see, it is equal to 1 over 2. Yes, so if it gives you negative pi over 3, well, it is still easy to calculate because it is easy to see the location and the reference is pi over 3. Okay, so I can subtract negative 6 pi, Shabab, no problem. You can subtract 4 pi. Yeah.
Doctor, why it's positive?
The fourth quadrant, Shabab. Cosine is positive in the fourth quadrant. We should memorize this thing, right? Who is positive, who is negative, depending on the location, huh? Yeah. If you do not memorize some properties, then you will be always, asking, what is this? What is this? So we need to memorize these things. Okay, the others are practice for you, Shabab. So we have,
Doctor,
yes.
can I solve them by transforming them to degrees instead of what?
Yes, please. Whenever you feel it is okay for you, just switch to degree, Shabab, if it is going to help you. Yes. Now, Shabab, we have only cosine and the secant are even functions. A sine, a cosecant, tangent, and cotangent, they are all odd functions. You see? So sine of negative t is the same as negative sine t. But cosine of negative t is the same as cosine t. All right? The even function, cosine. And also secant.
What does it make a difference? As odd or even function, does it make a difference in graphing?
Okay, let's just understand what is going on here. So you see, sine of negative t equals negative sine t. All right? Cosine of negative t is cosine t. Tangent of negative t is negative tangent t. For example, here.
Finished in 001, right?
So negative sine of pi over 6, because it is odd function, so which is equal to negative 1 over 2. But cosine negative pi over 4 is the same as cosine pi over 4 because it is even. So which is root 2 over 2.
Doctor,
Yes?
in the sign, we let the minus stay because it's in the fourth quadrant, right?
Yes.
Okay.
Okay. Now here is your famous question, Shabab. Which one of the following is even function or odd function or neither? And I wonder how much you remember from Maths 001, Shabab. Well, look at the first function. Here, the x square is what, Shabab? Anybody remembers x square? Even, right?
Yes.
X square is even function. How about sine x?
Odd.
Odd.
Odd. Now, what did you learn in 001? When you multiply even function with odd function, what is the result?
Neither, maybe.
Odd.
Neither.
Odd.
Yes. If you multiply, Shabab, it will give you odd. Now, to help you remember, Shabab, even like a positive sign, the odd is like a negative. All right. So when you multiply positive and negative, result will be negative. So,
Yes.
so it's going to help you basically. All right. And but when you add or when you subtract, that is different, you know. So for example, look at here, Shabab. Sine function is what? Odd, right? Cosine function is even. So when you add or when you subtract, it doesn't matter. Sine plus cosine or sine minus cosine. So result will be what? Neither. Neither, yes.
Sorry, doctor, but I have classes now. Can I
Yes.
leave?
So I'm going to leave rest of them to you, inshallah. So we'll continue from trigonometric identities, inshallah. Yes, you are free, Shabab.
Sorry, doctor.
Thank you, doctor.
One more. Can I ask? Okay.
Yes. Go.
The absolute value of x times cosine x is even, right?
Yes.
Okay.
Cosine is even, yes.
Doctor,
Yes, Shabab.
I have a question related to the previous quiz.
Yes.
Isn't it the first question has big numbers?